Energy. It is the compound that binds together all forms of matter, the motion of atoms and particles that can't be seen, but everything you know is comprised of it. The coffee you had this morning, or maybe drinking right now, is the reason why you're able to understand that this video is just a projection of light against the wall and my words are just sounds. Energy is always being used. Which raises the question, how much energy have I just used in the past 22 seconds? Yeah, the amount of energy I used drumming, recording, and presenting that 22-second monologue. Well, for the following, I'm going to use joules as a unit of energy to simplify and use a relative unit of measurement across all of my mediums. So let's start small. Drumming, that's 250 calories per hour, 1.3 calories per 22 seconds. That translates into 4.2 joules of energy in those 22 seconds. Roughly the same amount of energy in a tic-tac. Now, the camera I use is a Canon Rebel T6, which runs on a lithium-ion battery. That's 7.4 volts and 860 milliamps. With a little bit of math and website calculators, that comes out to 8,658 joules for about 30 minutes of filming, or 106 joules for 22 seconds, which is about a packet of Tic Tacs. The microphone I use is a Shure SM7B, which is the podcast microphone that everyone has. Now, the microphone doesn't use any power, but the interface I use does. For about an hour of recording, that's about 50,000 joules. And for the 22 seconds used to record the drums, that was 300 joules. The laptop I'm using to edit this video takes up about 4,000 joules. The lamp I use to light up the shot takes up about 800 joules. And the projector, the Panasonic PTEX800CU projector, that's being used to project this video right now, runs on about 8,800 joules per 22 seconds. So that leaves us with about 13,000 joules of energy for 22 seconds of playing drums. Considering that we're now 2 minutes and 30 seconds into the video, I have now used 76,000 joules of energy. Cool. So how much is that? If I kept on playing drums and filming it over the course of an hour, that would add up to about 2,200,000 joules, which is 2 megajoules of energy, which is equivalent to a stick of dynamite. So where did all this energy come from? Massachusetts mostly consumes natural gases to power the state. This is no exception for MassArt and my neighborhood. Gas and other heat sources is measured in BTUs, and 1 BTU is about 1,000 joules. A gallon of gasoline has about 115,000 BTUs inside of it. In theory, the energy in a gallon of gasoline has 121 million joules in it, or 121 megajoules. So, in 1 hour of playing and recording drums, the amount of natural resources I have used is 0.01 a gallon of gasoline.
What?
You're probably asking yourself.
You're telling me that 0.01 a gallon of gasoline has the same power of a stick of dynamite?
Yes, that's exactly what I'm saying. But this is the difference between energy that's released in an hour and in a fraction of a second. Now, if 1 hour is 0.01 a gallon of gas, then for 22 seconds, I used 0.0006 a gallon of gasoline. You might be thinking, that's not too bad. People burn through gallons of gasoline just to get to work every single day. But consider that these things do add up dramatically. Take, for example, the population of my city, which is roughly 60,000 people. In those 22 seconds, if everybody was doing what I was doing in those 22 seconds, that's 34 gallons of natural gas in 22 seconds. Now imagine the city of Boston with cars, heating, and food consumption. How many gallons of gas is that in 1 hour, a day, a week? Suddenly, that 0.01% of a gallon of gas becomes an overwhelmingly large amount. So what can I have done to save energy? Simple.